Okay, this is our last section of Chapter 7. This is 7.6, the inverse trig functions, and today's objective will be to find values of the inverse trigonometric functions. Let's begin with this thought. F of x equals tangent of x. Visualize that graph right now, okay? And it's not 1-to-1. The reason f of x equals tangent of x is not 1-to-1 is because it doesn't pass the horizontal line test. I can draw a horizontal line test just about anywhere, and it's going to intersect that function at infinitely many points. All right, so it's not 1-to-1. Doesn't pass the horizontal line test, therefore it cannot have an inverse. So what do we need to do then? Because there's an inverse tangent button on your calculator. All right, f of x equals tangent of x is not 1-to-1, doesn't pass the horizontal line test, thus it has no inverse. But if we restrict the domain of f of x equals tangent of x to, and you think about when you restrict the domain of a trigonometric function, so you can have the inverse of that function, you have to contain quadrant 1, and so you want the largest interval containing quadrant 1. So visualize the graph here, and I've only done this graph between negative pi over 2 to pi over 2. Do you see those two vertical lines right there? Well, in this restricted domain, okay, tangent of x is 1-to-1. So if we restrict the domain of f of x equals tangent of x to negative pi over 2 is less than x, and x is less than pi over 2, we get f of x equals tangent of x. Now this textbook, when they've restricted the domain of a trig function, they like to begin the tan or the sine or the cosine with a capital letter. You do not have to do that, but this textbook does that a lot. So we get f of x equals tangent of x. See? F of x equals tangent of x, all lowercase. But now when we restrict the domain, f of x equals tangent of x, and that is uppercase as a reminder. And this is not mandatory that we have restricted the domain, so tangent is 1-to-1. Passes the horizontal line test no matter where we put that horizontal line. It is 1-to-1. So our restricted domain is x such that negative pi over 2 is less than x and x is less than pi over 2. And our range is, well, I'm going forever towards negative infinity and forever up towards positive infinity. So the range is all y in the set of real numbers. All right. Now, and f of x equals tangent of x now has an inverse because it is 1-to-1. All right, so let's do a graph of the inverse here. Here's what we're going to do. Y equals inverse tangent of x. And I like to say inverse tangent of x as the angle whose tangent is x. The inverse tangent of x. Okay, now solve for x. Okay, so if I'm going to take this statement, y equals the inverse tangent of x, or y equals the angle whose tangent is x, what I do is solve for that x. I would take tangent of both sides. So on the left, I'd have tangent of y. And on the right, if I go tangent of inverse tangent of x, the tangent and the inverse tangent are inverses of each other, and they undo each other, leaving us x. So tangent of y equals x. And look what happened. Okay? We are interchanging the variables in f of x equals tangent of x. Because this f of x is a y, it's now an x, and this x, tangent of x, becomes tangent of y. And that's the definition of inverse right there. Okay, now let's do our graph. All right, now remember, since we're interchanging the variables, we're interchanging the domain and the range when we go from a function with a restricted domain to the inverse of said function. So our graph, notice how I had vertical asymptotes at negative pi over 2 and pi over 2. All right, now there's the graph right there of tangent of x. And let's do our restricted domain. Negative pi over 2 is less than x, and that's less than pi over 2. All right, now that's going to be the range of my inverse function. All right, so y then becomes negative pi over 2 is less than y, and y is less than pi over 2. And that's why I have those hash marks on the y-axis, negative pi over 2 to pi over 2. And that's going to create horizontal asymptotes. There you go. All right, now all we need to do a really good graph of y equals inverse tangent of x is reflect f of x equals tangent of x over the line y equals x. Well, by the way, my range, negative pi over 2 is less than y, and y is less than pi over 2. And what's my domain? Well, my domain is going to be, look at the range of tangent of x, y in the set of real numbers. That means the domain of inverse tangent of x would be x in the set of real numbers. Okay, so there we have this point right here, and let's reflect over the line y equals x, and look at what we get. The perfect graph of f inverse of x equals inverse tangent of x, or the angle whose tangent is x. And there it is. Okay, let's find the angle whose tangent is 2, and I don't know when tangent has an output of 2, so we're going to find it on a calculator. Inverse tangent of 2 on a calculator. Now you need to know what mode we are looking for. So let's start with degrees. So everybody get out your calculator and go to mode, which is right next to the second button. And let's go down. Right now I'm in radian mode, so I'm going to highlight degree and hit enter. Okay, now I am in degree mode, and I can punch this out exactly the way I see it. Inverse tangent of 2. So I'm going to go second, and you see the tangent key. Well, the second to the tangent key is inverse tangent. Inverse tangent of what number? 2. Close that parenthesis. And inverse tangent of 2 is, and I'm getting 63.434948882. Well, we're going to have to round that, and I don't know, I probably rounded that to the nearest hundredth. 63.43. Oh, I rounded it to the 10th, 63.4. And since they did not tell you what to round to, we're okay. Now, let's go radian mode. So go back to your mode button and highlight radian, hit enter, second quit. And now let's do inverse tangent of 2 again. I'm just going to go second entry, which is the second and the enter key. And I see my inverse tangent of 2 again on my calculator. Hit enter. I'm in radian mode now, and I'm getting 1.11. Or if I rounded to the nearest tenth again, that would have been 1.1. Let's see what I did. Oh, I went 1.11, so on that one I went to the nearest hundredth. It looks like I was thinking 3 sig digs on both of those. Who knows? All right. Now, find inverse tangent of -1 without a calculator. Now, the key here is this. I don't know the angle whose tangent is 2. But I can figure out the angle whose tangent is -1 without a calculator. And here's all I'm going to do. Let's first know what this means now. The angle whose tangent is -1. And I tend to say that all the time like that, rather than inverse tangent of -1. You can say it either way though. All right? Now, so tangent of x. Well, remember your reciprocal functions, all right? Tangent of x is 1 over cotangent of x, or you can write tangent of x in terms of sine and cosine. Sine of x over cosine of x. Now, I need sine of x over cosine of x to be -1. All right, so equals, and let's picture a circle right now. Okay, when does sine of x over cosine of x equal -1? Well, let's make this even easier. Let's take this and solve for sine of x. So let's multiply both sides by cosine of x, and you would get sine of x equals negative cosine of x. There you go. So when does sine and cosine have opposite outputs? All right, so x equals, and again, here's the circle I was talking about. And let's think of our reference angle of pi over 4 or 45 degrees if we're in degree mode. Right there. Okay, now see this angle pi over 4 right there? All right, well, sine has an output of root 2 over 2, and cosine also has an output of root 2 over 2. So at that pi over 4 right there, sine of x over cosine of x would equal positive 1. So tangent of x would equal positive 1. So I know that we need to have opposite signs, so I'm going to go, this is the reference angle for what angle in quadrant 2? And I'm going to quadrant 2 because cosine is negative and sine is positive in quadrant 2. That would be 3 pi over 4 right there. Pi over 4, 3 pi over 4 right there. And now, tangent of 3 pi over 4 would be sine of 3 pi over 4 over cosine of 3 pi over 4. And sine of 3 pi over 4 will be root 2 over 2. All right, the same as at pi over 4. But cosine of pi over 4 would be negative root 2 over 2 because this horizontal distance right here is now going in a negative direction over here in quadrant 2. So that works. Now, in quadrant 3, both sine and cosine are negative, and in quadrant 4, sine and cosine have opposite signs again. So the reference angle pi over 4, well, let's see, would it be 7 pi over 4 in quadrant 4? Yeah, so pi over 4 is a reference angle for 7 pi over 4. And at 7 pi over 4, this positive angle just like this, all right, sine of 7 pi over 4 would be negative root 2 over 2, and cosine of 7 pi over 4 would be positive root 2 over 2. All right, it's these coordinates right here, but the sign, the y there, has to be negative because we're down here in quadrant 4. So 7 pi over 4 would also work. But remember the restricted domain business, okay? We have to restrict the domain of tangent so we can take inverse tangent. And what is the restricted domain one more time? Negative pi over 2 to pi over 2 exclusive. All right, so 3 pi over 4 is not in this interval right here. All right, but 7 pi over 4 is a coterminal angle for negative pi over 4, and negative pi over 4 is in this window. So I'm going to go x equals, and I'm going to go right there, and that angle is now negative pi over 4. Coterminal angle, 7 pi over 4 and negative pi over 4. Very good. And that's how you deal with this. So there are some inverse functions like inverse tangent that you can do without a calculator. There are more that you must use a calculator to do, but it's great to know how to do this. Very good stuff. Okay. Does f of x equal sine of x have an inverse? Now I want you to picture the sine function. You've graphed it a few times now. Is it 1-to-1? That is not a 1-to-1 function, right? So no. All right, but can we restrict this domain and pick the largest interval containing quadrant 1, which would be from 0 to pi over 2, where sine of x is 1-to-1? Sure we can. So restrict the domain of sine and include quadrant 1. All right, there we go. This would be the largest interval where sine of x is 1-to-1, and it does contain quadrant 1. So that looks to me like negative pi over 2 to pi over 2 inclusive. So here's my graph right here. And the domain is going to be negative pi over 2 is less than or equal to x, and x is less than or equal to positive pi over 2. And what's the range? Well, we're still going from -1 to 1 inclusive. So the range is y such that -1 is less than or equal to y, and y is less than or equal to 1. All right? Now, note my hash marks, those are worth 1 right there. So I changed my y window a little bit right there. I kind of squished that sine function that you see up here on the upper left, but that's okay. Now, we can use this as a pattern to graph inverse sine. So, we're going to call this g of x equals sine of x, and this is sine with a restricted domain, so it's 1 to 1 from negative pi over 2 to pi over 2 inclusive. All right, and that does have an inverse. So g inverse of x equals inverse sine of x, or the angle whose sine is x. Now, remember, definition of inverse, all we are doing is interchanging variables. Therefore, we're interchanging the domain and the range. So do you see the range of our restricted trig function for sine of x is negative 1 to 1 inclusive? That has to become the domain of our inverse sine. So it's x such that negative 1 is less than or equal to x, and x is less than or equal to 1. Again, the range of sine of x is the domain of inverse sine of x. And the restricted domain of sine of x becomes the range of inverse sine of x. So my y's would be negative pi over 2 is less than or equal to y, and y would be less than or equal to pi over 2. And there you have it. Very good. Well, let's see if we can graph this now. Remember, inverses are simply reflections over the line y equals x. There's my line y equals x, and let's reflect. That looks pretty good right there, would you agree? And we can even talk about the coordinates of this point and this point. Because remember, we're interchanging variables, therefore we are interchanging coordinates. You see this point in quadrant 3 right there? That's x is negative pi over 2 and y is negative 1. Therefore, this point, the x would have to be negative 1, and the y would have to be the negative pi over 2. Same thing right here. Look at this point, the endpoint of sine of x with the restricted domain. The x is pi over 2, all right? And, oh, excuse me, all right, let me make sure I didn't write that down. The x is pi over 2, and the y is 1. So this point, the y would have to be 1, and the x is the pi over 2. And there you go. The perfect sketch of inverse sine of x. Isn't that cool? All right, this is important stuff. So, find inverse sine of negative 0.8 on a calculator. Now, down the road, I'm going to show you how to do this without a calculator. But for right now, we'll stick to our calculator because that's important too. And remember, I can say this, the angle whose sine is negative 0.8 if I would like. Well, let me turn on my calculator. And what do we want to be, degrees or radians? Let's start radians. So mode, I'm already in radian mode. So I'm just going to punch that out the way I see it. Second quit. And I'm going second. Do you see the inverse sine button is the second to the sine button? Inverse sine of what? Negative 0.8. There you have it. I double check, is it incorrectly? And in radians, I'm getting negative 0.927295218. I wonder what I rounded to this time. I bet you I did negative 0.93. Hey, I got one for a change. Good. Okay, remember, if they do not tell you what to round to and you are approximating, as long as you round correctly, we have to give you full credit. Let's go degree. Oh, no, we're not even going to do degrees. Wow. Well, I'm curious. What would that be in degree mode? So I'm going to do it. I won't write it down on here, but I'm going to go mode. And I'm going to go down to radian and then to the right and highlight degree. Second quit. And now I'm going to go second entry. And there's my inverse sine of negative 0.8. And in degrees, that would be negative 53.13 degrees, just in case you're curious. Now, this is similar to what I was talking about, how we could do this without a calculator, but it would take a great diagram. Now, this without a calculator, we're probably still going to do this with a diagram, but it's going to be a little bit easier because, again, negative 0.5. Isn't that negative 1/2? So the angle whose cosine is negative 1/2. I think you know when cosine has an output of negative 1/2. Okay, so the angle whose cosine is negative 0.5 or negative 1/2 or even negative √1/2. What do you think? So again, cosine of x has to equal negative 0.5. The angle whose cosine is negative 0.5. Okay, that means x would equal, now let's visualize this a little bit here. All right, so here's my circle. And doesn't cosine equal 1/2 at pi/3 if I'm in radian mode, or 60 degrees if I am degree mode? So there we go. See that 1/2 right there? Yes. So pi/3 or 60 degrees. Cosine of either of those angles is √1/2 or 1/2 or 0.5. Okay, so there it is. That's my reference angle. But I need this cosine to be negative. And isn't cosine negative in quadrant 2 and quadrant 3? Which would be 2 pi/3 or 4 pi/3. There's my two terminal rays right there. Okay, 2 pi/3 or 4 pi/3. Now, are these in the restricted domain of cosine? We better visualize cosine and see the largest interval containing quadrant 1 where cosine is 1:1. So there's a graph we've done of cosine previously. And if I go from the y-axis to, there's pi/2, so 0 to pi/2, and then I can keep going to pi right there. All right. So it looks to me like cosine is 1:1 in the closed interval from 0 to pi. Okay, right there. Okay, so let me see. Hey, well, look at this. 2 pi/3 is in that interval. So x can equal 2 pi/3. X cannot equal 4 pi/3 because that is not in the restricted domain of cosine. So we can find an inverse cosine. Nice. Okay, find cosine of inverse tangent of negative 2/3. Wow. Okay, on a calculator. Oh, on a calculator? Okay, so let's just punch this out. Again, radian mode. I wonder if I just stick to radians here. Okay, so let's go mode and make sure we're in radian mode. Oh, I went back to degrees, so I better change that. There we go, I'm in radian mode. Second quit. Now, on a calculator, I'm going to punch that out just the way I see it. Cosine of inverse tangent, that would be second tangent key, inverse tangent of negative 2 divided by 3. Close that and close one more parenthesis. Double check cosine of inverse tangent of 2/3. Wow. Enter. And let's see if I can go 2 in a row here. I'm getting 0.83 if I rounded to the nearest hundredth. Hey, approximately 0.83. Look at that. Now, wouldn't it be cool if we could do a problem like this without our calculator? Oh my, find cosine of inverse tangent of negative 2/3 without a calculator. So let's draw a pretty picture. Okay, first, what does this mean again? Cosine of inverse tangent, or the angle whose tangent is, negative 2/3. All right, so let's think about this. The angle whose tangent is, that would be this x right here, and it has to be negative 2/3. So tangent of x has to equal negative 2/3. All right, here's my circle. Sorry, I didn't complete it there, but that should be a closed circle. Now, when is tangent negative? Well, tangent is sine over cosine, so it would have to be in quadrant 2 or quadrant 4. All right, now let's think about the restricted domain of tangent was from negative pi/2 to pi/2. So that would be one of these two quadrants. So I'm going to have to use a quadrant 4 angle, okay, to diagram this. So again, there's my restricted domain. So restricted domain, x such that negative pi over 2 is less than x, and x is less than pi over 2. So that's the open interval from negative pi over 2 to pi over 2. So we need a terminal ray in quadrant 4. It does not have to be to scale here. So I just went right to my quadrant 4 right triangle picture. There's my terminal ray, and there's my angle x right there. Now let's diagram. Because what's the algebraic definition of tangent? Isn't tangent y over x? Or you SOHCAHTOA people, opposite to adjacent? All right. So again, tangent of theta, any angle, is y over x. Well, let's see. What would this y have to be right here? This is going to have to be the negative value. So that's going to be a negative 2. And then the x would have to be the 3. All right. Now, I'm going to need my radius here too. And that's not a Pythagorean triple, so I'm going to have to use Pythagorean theorem. Oh, by the way, let's go ahead and plot this point right here. What is this? Well, the x-coordinate is 3, and the y-coordinate is negative 2. Now, with that radius right there, I have everything I need, and I am Pythagorean theorem away from finding that radius. So, again, a squared plus b squared equals c squared. It doesn't matter which order for the a squared and the b squared. So let's go over here. And the a squared, I'd probably use that 3 for my a. 3 squared would be 9. B squared would be negative 2 squared, or 4. And that equals the radius of that circle squared, or the hypotenuse of that quadrant 4 right triangle right there. So if r squared equals 13, then r would have to equal radical 13. So r equals root 13 right there. I don't need the plus or minus because the radius of a circle is always positive. All right, put it in there. And now with this diagram, I've got it all. That's what it's about right here. Now look at this too. This x, this angle right here in quadrant 4, all right, that is the angle whose tangent is negative 2/3. That means cosine of that angle x is cosine of the angle whose tangent is negative 2/3. So I just need to go cosine of x. And of course, SOHCAHTOA or the algebraic definition, both would work here. So cosine of theta, I'm going to use a theta here. Okay, that's okay. Adjacent over hypotenuse. Okay, that's for your SOHCAHTOA people. But for you algebraic people here, that would be, what's the definition of cosine? It is x over r. And that's the way I like to do it because I have it all right there, nice and pretty. Okay, what's my x? Well, my x is that 3. Don't confuse this x, the x coordinate of the point, with the angle x they use right there. Okay, and they're doing that just to make sure you know the difference. But anyway, we've got a 3, and then the radius is root 13. And now you guys know you're going to have to, what? Rationalize your denominator. Equals, so I'm going to multiply the 3 by root 13 to get 3 root 13. And then root 13 times root 13 is 13. And there's my final answer. So the exact answer of cosine of inverse tangent of negative 2/3 is 3 root 13 over 13. That's exact. Now let's punch that out. And I bet we're going to get approximately 0.83. Let's check our work here. 3 second root 13. Now I know you can't see my calculator, so make sure you're punching this out on your calculator just to practice. Divided by 13. Okay, double check. 3 root 13 over 13. Boom, and there it is. 0.8320502943. We have a winner. All right, so again, think about, why do we need to be able to do stuff like this without a calculator and get exact answers? Well, if you're going to be an engineer, which I hope some of you might be thinking about that right now, if you're working for Boeing and you're designing jets, your measurements need to be exact when you're designing. All right, so this 0.83, might not be appropriate to keep the integrity of our jet from becoming compromised, okay? So we need exact answers. That's why engineers are so important. Oh, this is fun. All right. Hey, that was it, by the way. Oh, don't pick up my answer there for number 2. But your homework is page 289, do 2, 5, 7, and then 11 through 14. And you guys have fun. Send me an email if you have any trouble, any questions. I'd love to talk to you guys anytime. Have a great day.